So the first topic today is line power, and it's something that I think CenturyLink's got a little bit in their network. Traditionally, this is T1 powering or HDSL powering. That's where it kind of came from, the culmination or the beginning of it. It's been a very traditional usage. But about 10 years ago, a lot of people started looking at ONUs and smaller loads. And so at that point, they developed a standard for RFTV, and that's just a voltage limited plus or minus 190, 100 VA or 100 watt circuit, and that basically can provide power over the copper network, okay? So, what's the benefit? Well, what you get is you can project power from the CO or a central location where you have battery backup or a generator and you have significant uptime capabilities. You can project power from there over the copper network and be able to deliver a backed up, secured power solution for that load. Perfect example for these are, like I said before, ONUs or small DSLAM type devices. That's typically what's used, but also what we've been seeing a lot of, particularly outside of the US, but small cell or outside DAS applications as well. So it's an application that works for smaller power loads. Multiple pairs for extended reach. So what happens is, over the copper, you end up dissipating voltage as you propagate, right? Because it's just Ohm's law drives that. So what you end up with is potential for dropping below what the load can basically carry. What you want to do then is add copper or basically parallel copper pairs to reduce the resistance of the line, or drive more copper or more circuits out to deliver more power to this over different circuits, right? So that's kind of what's going on there. Downstream converter, so it's plus or minus 190 over the copper. At the far end, you basically take that plus and minus 190 volt power and you convert it back to 48 for use by the load, right? Because most everything's 48 volt. There are some 12 volt devices. We're actually coming out with 12 volt solutions. There are other 12 volt solutions in the market as well. Simplified installation. So why is that important? What's going on there is if you're going to pull a fiber out to a high bandwidth device like an ONU or a small cell or whatever that might be, you're already going to pull fiber. You've got copper that you can pull as well, like on the pole. You don't have to get an AC drop. You have less space taken up on the pole because you don't have a rectifier plant in there. You don't have to put batteries at that location. You don't have to send people out there. So you've got less physical space, you've got less equipment, so there's a lower cost of actually deploying that remote device. And the last thing here, reduce maintenance. What's going on there? Well, you don't have to go out to that pole, go climb the pole, go check the batteries every year or two, replace them every 3 or 4 years, because all the batteries are still back at the central office. So that's really the kind of benefits around line power. And again, this is one of the other things that typically comes up in the conversation. Plus or minus 190 is considered a hazardous voltage level. RFTV is actually really safe because of the way it's got a ground fault mechanism and also overcurrent capabilities to protect human lives, right? It's funny because in the lab I've actually walked back and touched it, and I'm still here. It's pretty funny because you won't do it twice, but it is actually inherently safe and completely effective. So remember, line power, you got a copper network out there already. You've got the capacity to drive that power out over those copper pairs. You can use multiple pairs to extend reach. The centralized battery plant keeps the whole system, the entire network of remote devices up and powered over that copper because it's still all the source of the power comes from the CO or the central location. And you reduce your CapEx spend because at the remote you don't have the rectifiers, you don't have the batteries, and you reduce your maintenance costs because you don't have to go and have constant maintenance on those batteries. Okay? That's it for this version of Power Talk.